You've probably heard it a million times, but microservices have completely changed how we build modern applications. They make everything more agile, more scalable, but they also bring this huge, often overlooked security challenge. See, it's not just about locking the front door anymore. It's like we've gone from guarding a single castle to trying to secure an entire sprawling city with gates everywhere. So let's break down how to do it right.
So here's our game plan. First, we're going to dig into why this is such a big deal. Then we'll get our tools straight, look at 3 different blueprints for handling authorization, and figure out how to pass user identity around safely. And to wrap it all up, I'll give you a few golden rules you can take with you.
All right, let's set the stage. Why is this even a problem? Well, it all boils down to a massive shift in how we build things. We've literally gone from protecting a single fortress to trying to secure a city with 100 open gates. I mean, there's no denying it. Breaking up those big, clunky applications into smaller, independent services, it's been a total game changer. It lets teams move way faster and system scale up like crazy. There's a good reason it's the go-to architecture these days. And this is the big but. All that distribution creates a huge question mark. When you have so many services all talking to each other over the network with tons of different entry points, how on earth do you secure the whole thing? That's really the heart of the problem we're here to solve. Just think about it for a second. Back in the monolith days, security felt, well, simpler. You had one big app, one front door. You put a big lock on that door, and you were pretty much good to go. But now, with microservices, the attack surface has just exploded. Every single service is a potential weak spot, and trying to secure all of them is a whole different, much more complicated ballgame.
So this new world forces us to think about security not as one thing, but in layers. You've got the edge layer, which is kind of like your border control. That's usually handled by an API gateway, and it's where you do your first big checks. But then, once the request gets inside, you're in the inner services layer, and that's where a whole new set of headaches begin. We're talking service-to-service communication, figuring out who's allowed to do what, and passing the user's identity from one service to the next without messing it up.
Okay, so before we can build a secure system, we've got to make sure we're all speaking the same language. Let's quickly go over the fundamental concepts, the building blocks that everything else relies on. First up, authentication. This is the simple part. It's the classic, who are you question. You know, it's just the process of proving you are who you say you are. Think username and password, an API key, whatever. That's step 1. And then you've got authorization. This is super important and totally different. It comes after you've authenticated. It's not about who you are. It's about what you're allowed to do. So once we know you're Jane, authorization is what figures out if Jane can actually view this document or delete that file.
This is where the API gateway becomes your best friend. Seriously, think of it as the single bouncer at the front door of your entire application club. By putting it right at the entrance, it's the perfect spot to handle all those initial authentication checks before a request even gets close to your internal services.
And finally, let's talk about the protocols that make all this magic happen. You've got OAuth 2.0, which is basically the industry standard for granting access. It's how you can log in with Google on another app without giving that app your Google password. Then there's JWT, or a JSON Web Token. The best way to think of this is like a secure digital passport. It's a little packet of information, or claims, about a user that can be passed around safely between services because it's tamper-proof. All right, with the fundamentals down, let's get to the real meat of this explainer. The 3 main architectural patterns for handling authorization inside our system. How do we control access from one service to another? First up, we have the decentralized pattern. The idea here is pretty straightforward. Every single microservice is its own security guard. The logic for making authorization decisions, what we call the policy decision point, or PDP, is just written right into the code of each service. Now, the one pro here is that the rules can be super specific to what that service does. But oh man, the downsides are huge. You end up with the same code copied and pasted everywhere, which is a recipe for errors and inconsistencies. And the real killer? If you need to change a simple access rule, you have to find all the places it's written, change the code, and then redeploy maybe dozens of services. It's just a nightmare to manage. So the obvious fix for all that chaos is to centralize things, right? And that brings us to pattern number 2. Here, the microservice doesn't make the decision itself. Instead, it makes a quick phone call and network call to a special, dedicated authorization service, that central policy decision point. It just asks, hey, is this user allowed to do this thing? And waits for a yes or no. And the big win is clear. All your policies are in one place. You can update a rule without ever touching your microservices. But you've just introduced a new set of problems. You've created a massive performance bottleneck. Every single authorization check now has to travel over the network, which adds time. And even worse, if that central service goes down, your whole system could grind to a halt. And that leads us to our third pattern, which is this really smart hybrid approach that tries to give us the best of both worlds. It's called centralized management with an embedded PDP. So the policies, they're still managed in one central place. But, and here's the clever part, they get pushed out to each microservice. This means the actual decision-making logic, the PDP, runs locally right there inside or next to the service. And this is really the aha moment. You get that amazing centralized policy management from the second pattern, but you also get the lightning-fast, super resilient performance of the first one, because there's no network call to make a decision. It's instant. And if the central policy server is down for a bit, no problem. The services already have the rules they need. The only real trade-off is that it can be a little more complex to set up that policy distribution system in the first place. Okay, so we've sorted out how a service can decide if a user has access. But hang on, how does that service even know who the user is to begin with? This is a huge piece of the puzzle. We need a secure way to pass that user's identity from the gateway deep into our network of services. So there are really two ways to go about this, and one of them is pretty common and, honestly, pretty dangerous. The risky way is to just take the user's original access token and pass it from service to service. The problem is, that token was never meant to be used deep inside your system. The secure pattern, which was pioneered by folks at Netflix, is way smarter. The API gateway checks the external user's token. Then, it creates a brand new signed internal token, they call it a passport, that only has the specific info needed for internal services. That passport is what gets passed around, keeping the original user credentials safely at the edge, where they belong. Whew! Okay, we've covered a ton of ground. So let's try to boil all this down into a few clear, actionable golden rules that any architect or developer can use when building a microservices system. When you actually lay the patterns out side by side like this, the choice becomes pretty obvious, right? The decentralized pattern just doesn't scale. The single central PDP adds way too much latency. But that embedded PDP pattern, it hits the sweet spot. We get high scalability with low latency, and we can still reconfigure it on the fly. It's the clear winner. So if you remember nothing else, remember these 4 golden rules. 1, externalize your authorization logic. Get it out of your business code. And that embedded PDP pattern is really the way to go. 2, defense in depth. Don't just trust your gateway, secure the individual services too. Assume the internal network isn't safe. 3, propagate identities securely. Use that signed internal passport idea and never, ever pass external tokens internally. And 4, and this is a big one, don't build this stuff yourself. Leverage the standards. Use OAuth 2.0, OpenID, Connect, and well-tested libraries. Stand on the shoulders of giants. So we've laid out a really solid playbook for the microservices we're building today. But, this world never stands still. We're seeing the rise of autonomous AI agents, more serverless functions, all interacting within our systems. So we have to ask ourselves, are these patterns we just talked about going to be enough? Is our current security playbook ready for the even more distributed, even more dynamic future that's right around the corner? That's the question I want to leave you with.